Hello, welcome to section 3.2 where we solve percent applications. And I know this is everyone's favorite where we do percent equations, applications, increase, decrease, simple interest, and then discount or markup. So let's just jump right into things. What number is 35% of 90? So remember, for these type of problems, we can just use direct translation. So because it says what number, that's our x, is equals 35%. Remember, we don't really calculate with percentages. We write them as decimals, okay? And then of means times. So that's it, right? Of is times, and then 90, of course, is 90. So what is 35.35 or 35 hundredths, rather, times 90? So that's going to be, hold on, so sorry, 31.5. So the answer is 31.5. That's the number that is 35% of 90. So let's do some more super fun examples. What number is 45%, which is as a decimal 0.45, of times 80? So 45% of 80 is going to be 36. What about this one? What number, you can use n also, is 55% of 60? So 55% of 60 is 33. Okay, 6.5% of what number is $1.17? So 6.5 translated as a decimal is 0.065, and then of means times, and then what number means x, so times x is 1.17. So what we need to do is, since this is multiplication, we divide both sides by by 65 thousandths. Okay, that cancels this out. We get x is equal to, and then we have 1 and 17 hundredths divided by 65 thousandths, and that's 18. Okay, so then let's do another one. This is where we find the percent. So 144 is what percent? So x expressed as a percent of times 96. So you don't have to write the percent symbol, but I just like to do it because so that you know. So in order to solve for x, we just divide by 96. And we're going to get it in decimal form, right? So you get 144 divided by 96, and that's 1.5. But then as a percent, we need to change it, right? 2 spaces, right? So x and as a percent is 150%, right? So you can say, you just leave it like that. All right. So let's continue using a problem-solving strategy to solve applications. So same thing, we read, identify, we name, we translate, we solve the equation, we check, and then we can answer. Okay, so let's go ahead. Dijon and his girlfriend enjoyed a nice dinner at a restaurant, and his bill was $68.50. He wants to leave an 18% tip. If the tip will be 18% of the total, right? How much tip should he leave? So the question is, what is 18% of 68.50? So x is 8.18 times 68.50, okay? So what is that? 18% of 68.50 is $12.33, so the tip is $12.33. Okay, let's do super fun percent example. Sierra and her sister enjoyed a dinner in a restaurant and the bill was, oh, so this is the same thing. So I'm going to actually skip this example. Let's do this one. One serving of wheat square cereal has 7 grams of fiber, which is 28% of the recommended daily amount. What's the total recommended amount? So basically 7 is 28% of what? You know, that's it. So then just divide by 0.28. And at this point, you can, you should be already practicing using your calculator also. So, so X is 25. So the total recommended amount is 25 grams. Okay, let's see. What more examples? Mitzi received some gourmet brownies as a gift. The rapper said each brownie was 480 calories and had 240 calories of fat. What percent of the total calories in each brownie comes from fat? So remember that percentage is part of, it's a fraction, right? Percent over 100. But it also, you can also think of it as parts of a whole, right? That's what a fraction is. So percent, so what we want is total calories that comes from fat, right? So the total calories in the brownie, so to get the percent of fat cals, right? Fat cals in the total calories, of the total calories. Sorry, this is really bothering me. We're going to have to divide. We're going to have the calories from fat divided by total calories. So then we're going to have 240 divided by 480. Okay, so that's just going to be 1/2, right? But then as a percentage, we need to express this as a percentage, right? So that's going to be 0.5. But 0.5 is 50%, right? So remember, it's percentages. We don't directly calculate with percentages. We calculate with fractions and with decimals. And then we convert to percentages later if we need to. Okay, so how do you find the percent increase? So to find the percent increase, we first get the new amount minus the original amount. So we know the amount of increase, and then the percent increase. It's the ratio of amount of increase, divided by original amount. And then if you want to change it from a decimal to a fraction, you can multiply by 100. So this will give exactly percent increase as a percent. Okay. All right. So then here we have the California governor proposed raise community college fees from 26 to 36 a unit. Find the percent increase. So the amount that it increased was the new amount, which is 36, minus the original, which is 26. So it increased $10, yeah? But what's that percent increase? That's going to be $10 over the original, which is 26. And then we're going to multiply by 100 to convert it to a percentage, okay? So we have 10 divided by 26, and then we're going to multiply that by 100, round to the nearest tenth. So this is going to be 38.5%. So this is percent increase. Okay. All right. Let's do another one. In 2011, the IRS decreased the deductible mileage costs from 55.5 cents from 51 cents. So this is the new, this is the original, okay? So what's the amount increase? It's new minus original. So new minus the original. So the amount increase is 4.5. So then the percent of increase is going to be the amount increase divided by the original times 100, okay? And that's going to be the percent increase. So percent increase. So we have 4.5 divided by 51, okay? And then times 100 to change it to a percentage. And it says round to the nearest tenth, so that's going to be 8.8%, okay? So if some of you are like, hey, how do I enter this in the calculator? Just, you know, if you want to speed up your homework, so you would do 4, you would hit 4, then you'd hit the point that is underneath the 3, and then you would hit 5, and then you would hit the division symbol, and then you would hit 51, right, 5 and 1, then you would hit equals, and then you just go ahead and hit times, and then you would do the type in 100. And then you would hit equals again. So the reason that is because when you hit equals and then you hit times immediately, it uses the answer. Okay? So try it out, see if you get the same thing. Okay, so to find the percent decrease, it's the same thing, except that now it's going to be less, right? So it's original minus new. It's going downwards, right? And then that's going to be decrease. Okay, so we're going to do original minus new this time to show the decrease. And then to find the decrease, we're going to do amount decrease divided by the OG amount times 100. And that's going to be the percent decrease. Okay, so the average price of gallon of gas was $3.71. The average price of the city in July, find the percent decrease. So the original was 3.71. The new price is 3.64 or $3.64. Then we're divided by, and we're going to divide that by the original, which is 371. Okay, so first let's go ahead and find the amount, which is $3.71, subtract $3.64, and that's going to be 7 cents. And we're going to divide that by the original amount, 3.71, and then that's going to be percentage. We're going to multiply that by 100, and that's going to give us the percent decrease. So that's going to be 1.8%. So percent decrease, it's 1.9%, actually, if you round to the 10th. Okay, so let's do simple interest. Okay, so simple interest is basically something where, when you deposit money into a bank, it collects interest, and usually it's simple interest, or it can be, there's different kinds. There's continuous, there's different kinds of interest, but we're first going to do the simplest one, which is basically when you have a principal amount invested for T years at a rate of R. That's the simple interest is called P. It's the formula for it is I is equal to PRT, where P is the principal or the deposited amount or the initial. Okay, and then R is the rate as a decimal, and then time in years, and then that will give you how much interest you earn. Okay, so we have I equals PRT. Okay, so Natalie deposited $12,500 in her bank account, so that's the principal, where it will earn 4% interest, so that's the rate. How much interest will she earn in 5 years? So rate expressed as a decimal is 0.04, sorry. So I is equal to PRT, so I is going to be 12,500 times 0.04 times 5. So then let's go ahead and do that. Let's see here. So 12,500 times 0.04 times 5. Sorry. So 12,500 times 400ths times 5 is going to, sorry about that. I keep messing up. 12,000 times 0.04 times 5 is $2,500. So that's how much interest she's going to earn in 5 years. That's pretty good. All right, let's do another one. Lauren loaned his brother $3,000 to help him buy a car. In 4 years, his brother paid him back the $3,000 plus $660 in interest. What was the rate of interest? So we have the interest, we have the principal, we have the time, but we don't know R. So we still have the same equation. We still use the same thing, except now we just plug in what we have. So we know that the $660 is the interest. $3,000 is the principal. The rate is we don't know, so I'm going to leave that as an R, and then we're multiplying that by 4. So 660 is going to equal 12,000 R. Okay, and then to solve for R, we divide by 12,000, and we get R is equal to what? 660 divided by 12,000. And that's 0.055, but as a percentage, so as a percentage, that's going to be 5.5%. All right, in 5 years, Gloria's bank account earned $2,400 interest at 5%. How much had she deposited? So now it's asking for the principal, it's giving you the interest, and it gives you the rate, and it gives you the time. So I is 2,400. P is we don't know. Rate is 5%. We're going to use a decimal, and T is 5. So interest is equal to PRT. So then that's going to be 2,400 is equal to P. We don't know what it is, so let's leave it as its letter times rate times time. Okay, so if we multiply 0.05 times 5, that's 0.25. So we have 2,400 is equal to P times 0.25 or 25 hundredths. So divide both sides by that. Okay, and we get P is equal to, so 2,400 divided by 0.25 is 9,600. Okay, so that's the initial. Okay, that's the initial deposited. All right, so let's do one more discount. So a discount rate. So let's say discount rate, the amount of discount is the rate times the original price, and the sale price is original times the amount of discount. So of course the sale price should always be less than. So Elise bought a dress that was discounted 35% off the original price of $140. So this is the rate. And this is the OG price. What's the A? The amount of discount. So amount discount is going to equal the rate expressed as a decimal times the original price is 140, right? Decimal, it's going to be 0.35. And so what is that? What's 35% of 140? 49. So that's the amount discount. So then B, the sale price is going to be the original price minus the amount of discount, which is 49, excuse me. And then that's going to be $91. Still expensive. Okay, so how do you find the rate? So Jeanette bought a swimsuit at a sale price of $13.95. The original price was $31. Find the amount of discount and the discount rate. So remember that sale price is equal to the original price minus the discount, right? Discount. Okay, so then this, we have $13.95 is equal to $31 minus something we don't know. So that's going to be our X. So let's solve for that. So minus 31 minus 31. Okay, so $13.95 minus 31 should give you a negative number, negative 17.05 cents, right? It's negative, but this is equal to, you bring down this negative X. So divide both sides by -1 to get rid of the negative, and you get the amount of discount, which is $17.05. But then the discount rate, so this is A only. So for the rate, this is the amount of discount. So the rate is the amount of discount divided by the original price. So rate is $17.05 divided by the original price is 31. So let's divide that by 31. And the rate is 0.55, but we need to express it as a percentage. So it's 55%. So discount rate is 55%. Okay, and then markup example. We have the markup rate plus original cost, and then the list price is original cost plus amount of markup. So it's always more, right? Because when you mark something up, you make it more expensive. So Adam's art gallery bought a photograph at original cost $250. Adam marked the price up 40%. So find the amount. Okay, so the amount of markup is going to be 40% of 250. Okay, so what is 40% of 250? 40% of 250 is $100. Wow, okay. So marked up $100. And then the list price is going to be the original cost plus the amount of markup. So that's just $350. Alrighty, so that's it for this section. Your homework is 67 through 151, every other odd. Good luck and happy studying, and I will see you in the next video.